recording? We're recording. Right. Let me open up my graphing program. So, come on, what's wrong with you? There we go. Right. Sine, cosine, and tangent graphs. So we're going to have a look at how to graph these and then graph variations of these. So the first one we'll look at is what does a normal, plain, simple sine graph look like. Let's use radians. Let's use radians. It doesn't really matter. So let's say we want to plot just plain old simple sine x. I think a lot of you would know what this graph looks like already. It starts at 0 and it goes up and down and back to 0, and this graph repeats. What's the word for repeating? What is it? No. Oh, come on, we did this word already. Correct, periodic. It's a periodic graph. Yeah? Anybody know what this upper point is? 1, minus 1, 0. Now we're using radians. What's this one? Pi, yeah. A half pi, yes. Yeah. I've never heard anyone say pi a half. It's an interesting way of saying it. There we go, yeah. 3 pi over 2. Or not pi 3 halves, you know. Right, okay. So that's your sine graph. Like I said, I have a feeling most of you have seen this graph before, right? Yeah? Okay, so please draw that in your notebook and we'll have a look at cos next.
Someone new.
No, this is an old student, we know him.
No, I mean like we've been late before.
Oh, okay.
I know that.
The cold mornings are tough, you know? They're tough. Right. Have we got this?
1 second.
Oh, yeah. It's not guaranteed every year. So, like for example, maybe it might not snow for 3 or 4 years, and then maybe every 5 years there might be a lot of snow. It's kind of a bit random. It's plenty cold at the moment, so the possibility of snow this year. Yeah, possible. Okay, we draw that? Yeah. So the next one is cos. The only difference really with cos is that it starts up the top at 1, goes down and up again like that. This point here, that one again is 2 pi, pi over 2. Isn't that right? Yeah, 3 pi over 2. And here is minus 1. And this is cos x. And again, it's periodic. It repeats. You probably have seen this one as well, yeah? Yeah.
And the length between sinus and cosinus is 1.
The what?
Is 1. Like distance between cosinus
What do you mean? Which distance exactly are you saying?
Like if you draw like on one graph cosinus
Yeah.
and sinus,
Yeah.
and like when the point between draws a line between like P2 and P, it will be
I
1.
mean, if I draw the sine graph on top of this?
Yeah, let me see. Yeah. Or will it be 1? No.
Are you talking about the horizontal or the vertical?
Horizontal.
Horizontally, I think the difference is pi over 2. I think.
So it's about vertical.
You're talking about shifting it. Yeah. We'll actually have a look at that type of stuff in a minute. And Ukrainian speakers, that's you, and where's Dasha? So it's sine and cos, not sinus and cosinus. And it's not p, it's pi. So just so you don't cut out by that. I know
Sine cos.
east of here, pi becomes p.
Yeah.
It's a kind of western eastern difference. So further east you go, it's more likely to hear it as p. What about p or pi? Okay. Maybe it's periodic, it goes back to pi then.
It just hurts if pi is correct and it's true.
That's possible too, yes, that's possible too. Alright, the next one now is tan. Does anybody know what shape tan is? What's different? Tan is quite peculiar. What's different about tan? The range is what, yeah? Yeah. Whereas here, it's between 1 and -1. So tan looks very peculiar. Oh, my goodness. Okay. Right. Tan goes like this. Ugh. Right, well, we know what this point here is obviously 0. Does anyone know where this break happens in radians? Pi over 2. And this point here? This is the tan graph, which is a little bit peculiar. What would you say is the value of tan at pi over 2? Oh, look closely at the graph. Tan at 0 is 0. Tan at pi is 0. Tan at pi over 2? Kinda, not quite, because infinity's up here. Undefined. It's worse than infinity, because if you look from the left you get infinity, but if you look from the right you get minus infinity. Can't be two values at once, so it's undefined. Does anybody know the reason for this? Yeah?
It never reaches.
It's something, yes, it's 0. Tan x is the same thing as sine x over cos x. And what's happening at this point here, that's becoming 0. This is why it breaks. Yeah. Now, we obviously don't get questions as simple as draw sine or cos. It's usually something like draw 2 sine or 2 sine x plus 1 or whatever. So we have to look at what's called transformations next before we can look at more complicated graphs. And the other thing is, which is good news, is I notice in the exam they never ask students to draw tan. And I think it's because it's peculiar like this. You know, if you look at the last, how many exams have there been? 28 exams or something like that. You know, in all 28 exams, there's never a question asking you to draw tan. Okay, so it's just something that they don't seem to do. So I won't be too concerned about tan in this lesson. I'll be much more concerned about sine and cos, which they always ask you to draw. Okay. Now, I have my graphing program which will help here. Can I scroll down?
1 second.
No?
Just like
Okay. Does anybody know the name for these dotted lines where the graph breaks? Asymptotes, yeah. Yeah. Or its full name? There's an adjective in front of asymptotes for this particular type of asymptote. Vertical asymptotes, yes. Yeah. Because you can have the horizontal ones too. Okay, you got that? Yeah? Right. So, let's use sine as an example. If I want to draw sine x, except make a slight change to it, I put a constant in front of the sine. What happens to the graph? Oh, you see, great. I see people saying this and people saying this. So, what do we, any strong opinions? No. Not this. No. It expands. Like this. Enlargement, yeah. No. So it's as if somebody took the graph, grabbed the top and the bottom of it, and pulled it like this.
Physics is F.
Yeah?
Something.
I want to show you here. Okay, so look.
amplitude.
Amplitude, yes, that's the word you're going for. Right. Okay, there's sine x. Now let me do, for example, 2 sine x. So I want you to use your imagination. Imagine you grab the top and the bottom and then stretch it. Okay? Oops. 2 of them. Okay, let's have a look. Can you see that? So the effect of the amplitude, the A, is to cause an expansion vertically. Okay, so if I was to describe this, you would say it expands the max min by A units. Right, so that's our first one. And it's also worth saying what happens if the A was negative. So as a sort of, by the way, if the A is negative, it still expands it, but it has another effect. Does anyone know? Nope. Nope.
Oh, then like
Nope. Nope. Nope.
moves.
What is it? Reflects. The graph flips upside down.
Oh,
So I'll show you here, if you look, if I say minus 2 sine x, look at the blue graph and imagine you flip it upside down. Okay, so look at the blue and imagine it being flipped upside down. Let's see what we get. You get that black one there. Can you see that? Yeah? So it gets flipped upside down. So we say it reflects through the, what's the correct vocabulary here? Reflects through the x or the y? Reflects through the x. Yeah. Okay, write that down. That's transformation 1. There's 4 transformations in total. Yeah, if A was like a half, if it was 0.5, then yes, it gets multiplied by a half, so it looks smaller then. Yeah. In my experience for the exam, I cannot think of an example where they made A less than 1. They usually make A more than 1. Okay, we can go to the next transformation. Yeah, you could probably imagine what transformation I'm going to have a look at next. We'll put a constant in front of the x. And again, we can imagine the constant as being more than 1, like 2 or 3 or whatever. Does anybody know what happens here? Nothing to do with the amplitude this time?
The wavelengths?
Yes. Yeah. What happens horizontally? It shrinks. So as you said, the wavelength, the period shrinks. So let me just put that here. You shrink the x-axis
Shrink
by
is like get shorter, yeah?
b units, huh?
Shrink is get shorter.
Yep. Yeah. Or compress, words like this.
Compress is universal.
Compress is a new word?
Universal, like it. I think it's like reflects to a lot of languages.
Yes, yeah.
That's
Compress is a very broad word. Yeah. And again, also, the effect of the b being negative. If b is negative, then just like previously, we get a reflection. But let's have a look at a graph here to help us see this. Okay, so there's my sine x. And let's say sine 2x. So can you look at the red graph and picture somebody compressing it? So for example, this point here, which is at pi, will get pushed down to a half pi. Because I'm the 2 here will half everything. Let's have a look. Can you see compressed? Yeah? Yep. Okay, so we can write that one down. Okay. Next one. Oh yeah, you want to see it reflected, yeah. Okie dokie.
So it shrink and reflects.
Only if it's negative. Yeah, so she was asking me to show an example of when you have a negative. So let me just... I'll draw... There's sine 2x, okay? And then let me draw sine minus 2x. So, if you picture this being on a piece of plastic, it's like you flip the image around. Okay, so this hill here, instead of being on the right, should be over here on the left. So let's have a look.
Yeah, because it could look like it's like through x-axis, but it's through...
Yeah, actually it's interesting. It looks like it's been flipped upside down, but it's actually, yeah, it's the in this case, it's horizontal.
Can you show the...
Which one? Yeah, this one here. Is that okay? Is that what you were picturing?
Yeah.
There's an interesting point here. My graph I drew of y equals sine minus 2x. For this particular one, that is the same graph as if you were to draw y equals minus sine 2x. Now, that doesn't always happen. It only happened for this particular case. But if you were to graph both of these, they would look the same. There's a reason for this, which we'll see later, though.
Can you go to the graphs for a second, the ball, please?
What do you need to see? Yeah? Blue, red was the original and blue is the negative one. Yeah? Continue? Yeah. Right, the next one. Y equals sine x plus c. So you were giving me the physics words for these. A was the amplitude effect, B had a wavelength effect, and C has a... Oh, no dictionary.
What was it for?
Anyone know the physics words? P. No, that was more with the B, the wavelength. It's good vocabulary.
B?
P, yeah. Well, he's spelling it with a silent P at the front, so... anything else? No. Well, I don't hear any suggestions from you now.
Because like if I'm free, I can say, but if someone is
No. Pretend no one else is listening to you. What's your answer? Beginning with P.
What was the second?
Oh, no. Petroleum, maybe? No? Anything else? Pressure? Position? Okay, so if you're looking for the physics word that refers to the C, it has an effect on what's called the phase of the graph. No, don't pretend you knew. Right, so the A has an effect on the amplitude, the B has an effect on what's called the wavelength, C has an effect on what's called the phase. So does anybody know how this affects the graph? What do we mean when we say the graph's phase is affected? Shift, very good, yeah. Which direction? X or Y? In this case? X. Yeah. So, suppose I had, let's take an example. Suppose I have, I don't know, sine x plus, let's say, pi over 4. What will be the effect here?
It will move.
Move to the right, move to the left. Which is it? Move both. It'll take a step to the right, then it'll take a step to the left, and then settles down. This isn't quantum physics now. This is just normal physics. Okay. What'll happen? Will it move left or right? Left. It'll move left. Actually, it'll move left. And you have to be careful with that because of the plus here, you might think it'll move to the right. Yeah?
Can you remind us of like signs and like for example if we have the point where the graph moves, if like it's plus, minus, or it's like...
Yeah, so what happens here? If it's a plus, it's actually to the left.
Yeah.
And if it's a minus, it's to the right. It's opposite.
What about up and down?
Up and down we haven't done yet. We'll do that in a moment, yeah. We actually haven't done that one yet. So I'll draw it, but before I do, can you picture this moving to the left pi over 4 units, which pi over 4 is how much is that? That's about just a little piece like this. So if I draw that, there you go. Yeah. Can you all see that? The blue is pi over 4 units to the left of the red. Why is it like that? Why not? So, let me put it to you like this. In this graph here, what value of x will make sine x 0? 0. If x is 0, then sine x is 0. So, can we agree that 0, 0 is on this graph? Yes? There it is there, in red. Now, let's look at the blue graph. What value of x will make this have a value of 0? Minus pi over 4. So we can agree that minus pi over 4 and 0 is on the graph? There it is there. Yes? Yeah? Oh, he just wanted to know why it moves to the left. You can just trust me on this, but he doesn't trust me. So he wanted a reason.
Me too.
Yeah. Wait, you don't trust me or you don't trust him? No comment. I see. Alright, continuing now. Let me put this in language here. So, what's the effect here? Does anyone know the verb? A little bit more technical than move. Yeah, translates the graph C units right. And the effect of the minus is to just move it, oh sorry, C units left. And the effect of the minus is to move it right. Okay?
I will better draw minuses and translate the graph C uses through
Yeah, if you want to
x-axis,
say
yeah.
if C is, translates the graph C units left, if C is negative, then that means you translate right. Yeah? Can I scroll down? Yeah? Okay. Y equals sine x plus d. So what's the effect of this plus d at the back? Yeah, now if the d was positive, it is going correct, yeah. Yeah, so the effect of the d is to raise the graph d units. And I think it's pretty obvious what would happen if the d was negative. Yeah. I'm not sure if the d has a physics name. I could have a guess at it. Because it we,
I know. Yeah.
well, I would call it like a displacement. No, I think it might be called like a displacement. I'm not sure. Because usually the D isn't so interesting. The A, B, and C are more interesting.
But this rules like works for cos and
Yep, and
tan
time.
as well.
Yep.
Not for cos.
Okay. We got that? Yeah. A quick graph of this. So. Let's draw. Okay, I know.
Can we cosine?
I'll do cosine as the next example. Right, can you all look at this graph and now imagine it's lifted, it's raised by 1 unit vertically. So this is what you would get if you lifted 1 unit vertically. Can you all see that? Do you notice how it has a lowest point of 0, whereas previously its lowest point was -1?
Can you please make it for cosine? as well?
The okay, fine. You want?
Yeah, because I have no space on sine graph.
Oh, I see. Okay. What do you want? Cos x?
Cos x plus 1.
Right. There's cos x,
Yeah.
and then cos x plus 1. Is that same idea? Raised 1 unit.
Is it possible to fall between 1 and -1?
What exactly?
1 and 2 plus 1 and 2.
Oh yeah, of course. Yeah. So I'll draw that for you. That should be in between the two. Yeah. You got that? Yeah? So now, the hard example, where we have a graph that has all 4 in it. Okay, so we have to do it step by step and just take our time. Okay? Can I scroll down?
Yep.
Yeah. So let's say, an exam question might be something like graph let's say y equals 2 cos two x plus pi plus 1 in the interval, let's say 0 to, let's say, 4 pi. Okay? We'll do this one together. I'll show you the technique to make your life easier for this. Now, this question, I don't know, it confuses students. I don't think it's hard. It's not as hard as you might think. So my tip here is you start by making a special type of table. You write down here, oh, well, before you even start, it's more normal to write this in the form where, how can I put this? The x doesn't have a coefficient. So you would write it like this. Y equals 2 cos bracket 2 bracket x plus pi over 2 close plus 1. You see what I've done? I've taken the 2 out. Okay. Now the reason you do that is those 4 rules I gave you, if you want to use them all at the same time, you have to separate these two into 2 separate effects. So what you're doing is you're saying, we'll have a look at what the A does, we'll have a look at what the B does, then we'll have a look at what the C does, and then we'll have a look at what the D does. Okay? But by having it mixed together like this, it actually becomes a little bit confusing on which you should consider first, the C or the B. So just to prevent any confusion, it's just much easier if you factor out the 2. And then this is A, this is B, this is C, and this one here is D. Once you have that clear, then we can start. So before you begin, factor out the 2. Okay. Start, end, min, max. I'll call this item. Yeah. Well, I'm not going to scroll down, so I'm going to fill out this table. So first you write down here what graph you're looking at. You're looking at sine, cos, or tan. We're looking at cos. Cos normally starts at 0 horizontally. Sorry. If you want, that's x start, x end, y min, y max. Okay? And where does it end after one period? No. Yes. 2 pi. What's the minimum y value? Okay. Just take a second before you answer, okay? -1. And the maximum y value? There we go. Okay. Are we all happy with that piece of information, yeah?
How can I know it's at?
Say again?
How can I know it's at?
That was, do you have the graphs I drew earlier? There. The original cos graph ends at 2 pi on this graph. Can you see? Yeah, that's why I know it. Okay, are we all right with that? Now, what we do, we start adding in the A, B, C, D. Okay? So, what is the effect of the A? Does it affect start, end, min, or max? Picture the graph. What does it affect? Min and max. Question yet? Oh, she just asked me that. Okay, if you go back to the original cos graph.
Is it always like that?
Yeah. Cos is always -1 to 1, 0 to 2 pi. Yeah. Okay. Now, it's good to ask questions. I want to make sure we are completely clear before we go on to the next row. We all clear? The first row is just plain old cos x. Nothing but just plain old cos x. Yeah? Now, I think somebody said it, what's the effect of the a? Which one does it affect here? Min and max. These guys are unaffected, but what will happen to my min and max if I consider the a being 2?
Times 2, so it's minus 2 and 3.
We are stretching. So now it is down to minus 2 and up to plus 2, because the a is 2. Remember, we said it expands. That was the first rule we did. Now the second one, what effect does the b have here? On the x. And the effect of it? Oh no. What does the 2 do on the b? Shrinks it. By how much? 2. So, instead of finishing at 2 pi, it will now finish at?
1.
No. Correct. 1 pi. Yep, yep. And are these affected? They are not. Remember, we just said it affects the horizontal. Right, the c, the phase. What will be the effect of the c, which is in this case pi over 2? What did we say the pi over 2 does? Moves it left. How much? Pi over 2. So it does not start at 0. It's been moved to the left. Where will it start? Minus pi over 2. And it does not finish at pi. It'll now finish at?
Half pi.
Thank you. Half pi. And the min and the max are not affected. Yeah? Are we okay with this? Yeah? Right. D, the plus 1, what will that affect?
The 1.
The y, good. So these are unaffected. And what do we get here? Now,
Minus 1.
good, okay. And this one? 3. Because we've lifted it up 1 unit. Okay? Now, these are the numbers which will help us make our graph. Yeah? Just, yeah. Can I scroll down to here? Would that be okay? Yeah? I know what you're saying. 1, 2, 3. Minus 1, minus 2, minus 3. And then let's call this point here. Actually, I don't know if I'll have enough space. I'm going to change this. 4 pi is a little too big for me to draw. I'll make it 2 pi. Be a little bit easier to draw. Okay. Yeah, okay, that's better. That's pi over 2 there. And then that's minus pi over 2 there. Okay, and I'm just going to look now, I'm changing it to make the graph between 0 and 2 pi. Alright. So, here's my tip for the exam. When you're drawing this graph, you need, if you want to do it nicely, you need 2 pencils, or even 1 pencil. 1 pencil for light work, and then the other pencil to actually draw in the answer. Okay, so I'll use brown here to be, you know what I mean by construction lines. You know, so first you mark off where we start. That's minus pi over 2. So in a light pencil, there's minus pi over 2. Then, whoops. Then you mark off where you finish. In this case, it's end here. Pi over 2.
Does it always end the same? Start and end the same?
Oh, like this? No, actually, that was just a coincidence for this question. It could have been, you know, minus pi over 2 and 10 pi. the way it worked here. Is that okay so far? And then you mark the min and the max. So the min here is -1, which is going to be this line. Can you see? And then the max is 3. So can you see I've made a box? Can you see that? This rectangle. Then what you do is you split this rectangle into 4 equal quadrants. Okay? So how high is this rectangle? How many units? 4. So what is half of that? 2. So you split this down the middle here. 2 units from the top. And this is nice and easy to split. It goes from -π/2 to π/2. So where's the middle? Yeah, that's easy. That's nice, isn't it? Right in the middle there. 0. Okay. Now, what you need to do next is copy this to the end point which we need. Where do we need to finish? At 2π. So there's pi. There's 3π/2. And then here's, sorry, that's a bit ugly. That's 2π. And that's 3π/2. So, you know, copy, paste. Copy, paste. A little harder to do with a pencil, but it's the same idea. How wide is this box? How many units wide? Pi units. So if I was to draw it, it would go all the way to here, wouldn't it? And the middle, where would the middle be? Pi. Very good. Okay, now I'm going to just colour this in a little bit more so I don't confuse myself, because I'll easily confuse myself. There's the first box. Copy, paste. There's the second box. Now, am I at 2π yet? No. Yeah, so how much of a box do I have here? I only need to go half a box, don't I?
Yes.
Yeah, so I kind of have to stop. I need to stop here. And where do I start on this graph? I need to start here. So what you do, you fill in the first box with a cos. With 0 to 2π.
Why we start like
Why did I start at -π/2?
Yeah.
Because of this. I must always fill in this box first.
Yeah.
So
and start with -b over 2.
Yeah.
So it's 0, yeah.
So I start by filling in cos in the first box. So what shape is cos? Do you remember?
Yep.
Starts high, middle, or starts high? Starts high, and then goes down here, and then up, and then down, up, and then down. Now I fill it in. I have to start at 0 and finish at 2π. So do I fill in this graph? No. So it's here. And let me just put, it's hard to see now, let me put in blue the y-axis and the x-axis. So we're looking, our final answer is the blue here and the red. And that's the answer. Now, before you copy that, let's check how good my graph is. Can someone call back to me the graph? What was it?
2 cos
Yeah.
bracket 2x plus 5
Yeah.
plus 1.
Plus 1, like this. Yeah, and we want the graph to start at 0, roughly. So I'll just say start at -1 and finish at 2π, which is about 6.28. So I'll just say 7 here. Yeah, okay, so I'll draw the graph here. Right, are we ready? Let's see how close I was. So I should be a little bit under at the start, mostly over, a little under, mostly over, a little under. There we go, nice. There we go. Oh, I can't even tell the difference. Yeah. All right. So that's how we make these graphs. Okay. No, I'll give you a minute to write it down. Don't worry. Yeah. Yeah, because we're building it up. Yeah. Okay, I'll give you a minute to write it down. There you go.
No, I just want your exact graph.
Okay. Yeah? Well, in the exam you're going to need to learn how to draw it, so good practice to copy it, yeah? No, not necessary. No.
How accurate should it be?
Well, the way the marking goes, this could be a 4 or 5 mark question. So the marking scheme might say something like 1 mark for them having the correct upper and lower limits to the graph. And then it might be 1 mark for having the correct wavelength. Then it might be 1 mark for having the correct shape, and so on and so on. What am I looking at? Nope. Because you're hitting the x-axis. Yeah, should be hitting the -1. Yep. So you would lose the 1 mark for having the max and min correct. Did you copy that? Yeah.
That's why I didn't draw it.
Now they don't seem to ask it anymore on the exam, and they told me it's not on the exam anymore, but I wouldn't always trust what they say. It used to be a question in the exam where you have to go backwards. They would give you the graph, and you have to write down the formula. Yeah. So I don't know if you would think that would be easier or harder. But I don't, they claim that they're not doing that anymore. The student just needs to know how to make the graph, not the opposite. The opposite, I mean, is some exam questions used to give you the graph and ask you for the formula. So you have to be able to basically, in your head, go sort of backwards or infer what the A, B, C, D were.
Is it everything that we need to label?
Yeah, a lot of construction lines got covered up here. I would absolutely have to make the maximum clear as 3, and I might want to emphasize that this is -1. Yeah. Yeah.
Why do we decide to put a line in half?
Where?
Between the 1 and 3.
Yeah, because the cos graph and the sine graph, these graphs are nice graphs because they always split a rectangle into 4 equal parts. Always. So if you have a sine graph, I know for a fact it will perfectly fit into this window like this. And if I have a cos graph, I know it will perfectly fit into this window like this. So this is a fact about the graph. They perfectly fit into 4 quadrants like this. So it's helpful for the construction to use that fact. Yeah?
What was our first step?
Oh, here it is. Here's the 4 steps. Cos A.
The first one. It's a graph.
Oh, you'll have to watch the video. Because I go through all the
No,
steps.
I
So.
just need the first one.
You just need the first one. Okay. The first one, which part?
The graph to do the.
Oh, yeah. Do the dotted line at 3, dotted line at -1, dotted line at -π/2, and dotted line at π/2. So you make a rectangle.
Yeah.
Okay. Did you copy that? Yeah. So, yeah.
What if the equation is minus?
Yeah, so which one do you want to put the minus on?
At the A.
Like here. Right. Can anyone tell me what would happen if I put the minus on the 2? The only step that's affected is the last step when you draw the graph. When you fill in the first cos, you fill it in upside down. So my graph would look something like This, oh, wait, actually, no, there's a bit more of a difference, sorry. I won't go through the full steps, but I will look at that one with the minus just really quickly. Guys, can you look up? So imagine that there was a minus here. Okay? Which step gets affected? Which step gets affected? It's really when you're putting in the graph, isn't it? But also minimum and maximum, doesn't it? Yeah. So what I sometimes like to do, so I'm not worrying about the minus, is I take it out. So I would do this at the beginning. Minus 2 cos bracket 2 bracket x plus pi over 2 bracket bracket. And then this one is minus 1. So mentally for me, it's easier to take the minus out, forget about it, and then at the very last step, remind myself that I have a minus that needs to go on everything. And then the graph, I flip it upside down. Now, I'm not flipping this red graph upside down because what's different here? The minus 1. And what one will that affect? The min and the max. What would it be instead? It'd be down, wouldn't it? It would be minus 2 and what would that be? No, sorry.
Well, where to get put the minus 1?
Hang on. Where is it gone? Which one is it? D. Yeah. This would be minus 3 and 1, isn't it? Yeah. Yeah. So my graph, instead of starting at minus 1, will start at minus 3. So that will look, you know, sort of more like this. Yeah. And then I remember that I have the minus, so this would then flip actually. So, oh jeepers. Something like this. Let's see. Let me put the minus here. So I'm thinking it will look like it'll actually just be under the red. Maybe. Oh, it'll reach all the way up to the red? Okay, let's see. Oh yeah, it's way too low. Yeah, okay. There it is there. So it...
So it just looks to the y-axis, yeah?
No, it looks like it's just upside down. This is what I was originally going to say, but I wasn't 100% sure. 1. Y equals 1. This is what I was originally going to say, but I wasn't 100% sure. At the last step, when you're filling in the graph, you just fill in upside down costs. You know? But I wasn't 100% confident with that, but it looks like, yeah, it is that. It's just when you fill in your costs, it's upside down.
Can you please remind us how we find minimum and maximum?
Min and max?
Yeah.
Which one here?
Yeah, like
Well, it's always minus 1 and 1.
and next ones?
Multiplied by A.
And then multiplied by...
And then add D.
And then ND.
Yeah.
No.
Alright, I'll let you try these for a few minutes. They're not easy. They're not always easy. I'll only ask you to do ABC. If you can do ABC, then that's great. Yeah. 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 If it's not interfering too much with the graph. No, you can work together, but do so a bit quieter, please.
So originally cosecant.
Next semester, I think.
I don't need anyone. But I was quite excited that we will have differentiation next.
Yes, that's coming up.